Let's begin then. My name is Viktor. I will not bore you much with what I do because you're probably not much interested, so we're gonna skip directly to the topic. But first, a small intro. The reason why I personally started working with microservices, scalability, and all the things that I'm gonna speak about is basically out of complete frustration. And frustration because for a long time I was very much involved in testing, in continuous integration, delivery, deployment, and many other things. And I think that at least most of the times I failed to accomplish my goals, and the reason is very simple, because I did not realize at that time that it's not only about applying new practices and trying test-driven development or whatever you're trying to try. But the major issue is always architecture. We're kind of failing to change our architecture in according to the practices that we are trying to apply. And the way how things are moving, even though it does not apply always, microservices are really something that will help not only in architectural sense, but with other practices that you're doing. It will help you be more agile, it will help you deliver faster, and many other things. So, we cannot speak about microservices before understanding what do we have today, and what we have today in most cases are monolithic applications. What are monolithic applications? They are applications delivered and deployed as a single unit, right? You have one application that you develop during years, and it becomes bigger and bigger and bigger and bigger, until nobody really knows what's inside. Until we reach the point that what took us one day to develop initially, after a year takes us a week, after 5 years it takes us a month. And the reason behind that is that we are increasing complexity at all times. Now there's nothing wrong with increased complexity by itself, because that's what we do. We solve complex issues, like what Pete was saying. But with monolithic applications, it's inevitable that complexity increases much faster than with other types of architectures, simply because you start designing your application, you create your layers, you're very happy because you have 4 layers, for example, and then after a year you realize that you have 57 layers, you need to implement 78 classes in order to just develop a simple feature or something like that. So with time, the complexity increases, and it increases exponentially. And apart from complexity, it increases size. And size is extremely important. It's important because the bigger something is, harder it is to test it. The bigger something is, harder it is to develop, harder it is to learn how something works. Everything is harder when something is bigger. That does not even apply only to software, it applies to almost everything. It's harder to drive a big truck than a car. And it's harder to drive a car than a motor, simply because big things are harder to learn, are harder to handle. And so with time, an increase of that complexity, our ability to develop efficiently is dropping, simply because of all the complexity that we are putting into application. It needs to be taken into account for every single feature, for every single refactoring, for almost everything that we do. Then another problem with applications that we are developing, when we are developing in them in monolithic way, is that change is extremely hard. I bet that many of you had situations that you wanted to change something. Let's say you see a class that you want to refactor, and then somebody else comes and don't do it, because we don't know what will be affected by that, right? Don't change it, it works, just keep it there. And it's normal, and it makes certain sense, because if your change might affect some other part of the system, you might not want to do it, or it might not be valuable enough for us to bother with it. And scaling is probably the most important aspect of what we do, because we develop software for some business. Some of us might develop it as a hobby, but we do business. Either for our customers or our own business, but it's always for business. And the main thing that every business wants to do is to scale. In a very broad sense of words, right? They want to increase their business, they want to scale their software, they want to scale their demand, they want to scale their teams, they want to scale everything. That's what we eventually want to do. We want to become more successful, and more successful means scaling in many different forms. And one of those forms of scaling is software. Because, for example, your number of your users increased, and you need to scale your application to be able to support the increased traffic of your demand. Would be one example, right? Now, the problem with monolithic applications is that it's not that you cannot scale. You can scale, of course, because you take that huge monster, multiply it, and put it on a second server, and then take it and put it on a third server. So you do scale, but the problem with such a scaling is that you're multiplying everything, and not everything needs to be scaled all the times, because only part of your application is a bottleneck. You cannot, almost never the whole application is a bottleneck. One part of it is a bottleneck, and what you truly want is to scale the part that is a bottleneck. But you cannot do that because your application is one whole unit. Your application is not something that can be separated easily and scaled and moved around easily. So we start with a nice design, and we end up with something like few layers, and we are very happy, right? Because we are very proud of it, and it's so easy to develop, and we like it, and we even write blog posts how fantastic is our new architecture. And then after some months, then you start coupling objects like crazy. And it's not that because you want to do that, but because it's sooner or later it's inevitable that you start coupling things and doing things that you shouldn't do, simply because you have a deadline, you need to do it for yesterday, right? And you have a new programmer that is not really familiar with your architecture. He just started yesterday, and he's gonna do stuff that he shouldn't do, right? Now, the best way to prevent people from doing stuff that they shouldn't do is not to give them that as an option, right? And that's when you'll see later microservices come really handy, because you cannot couple two different services. You cannot call methods that are not supposed to be called from certain point simply because they are physically separated. The only way of communication is API, but we're gonna get there. And I'm gonna skip this. This is the part of scaling. You need to multiply absolutely everything. You want to scale application, you multiply until your company goes bankrupt, more or less. So then people microservices are a new thing, they're a hit, they're hot, which is not true. They're not new at all. Microservices exist for a very long time. The reason why they're a hot topic today is that only recently it is efficient to use microservices. Until maybe a few years ago, we couldn't use them because we didn't have tools to allow us to use them. Actually, we could use them, but actually the cost of creating microservices, using microservices architecture was much higher than the benefits. But that changed recently. So microservices are, I like the definition, I think that Dan North said it, or quoted somebody, that for him the size of a microservice is, the perfect size is the size that fits into his head, meaning this should be the size of your code. What he really wants to say is not that it should be only 50 lines of code, but one of the great things about microservices is that they are simple, simple to understand because they're relatively small. Any newbie, if I give you the microservice written in Scala and you never knew Scala, how hard would it be for you to understand 200 lines of code, even if you never coded in it? So they're really small. What is small is to be defined. It depends really from case to case. But nevertheless, they're much, much smaller than applications that we're used to create until now. So we create the whole system by decomposing it into smaller units. And then out of those smaller units, we grow the whole system, which is not actually really different than how we do monolithic applications. The major difference is how we split them, because monolithic applications also have smaller units. You have classes, you have layers, you have stuff. But in case of microservices, the real difference is in how we split them, meaning that we split them vertically. There is no horizontal layer of this or that. Simply there is as many microservices as there are functionalities of our system, or what the system should do. So another important thing about microservices is that they must be autonomous. They must be completely independent from anything else. If you have dependency between services, then you're not doing microservices, truly. And that's actually where SOA failed a long time ago, service-oriented architecture, right? Is that initially the idea behind SOA was exactly the same as what is the idea of microservices today. We just had to change the name for a simple reason that SOA got so polluted with enterprise applications like ESBs and all that, that the message or idea behind it got somehow lost. But now it's back with a different name. So the third very important thing is that the absolutely only way that you can communicate with the service is through API. And that's how we accomplish basically decoupling, complete decoupling between things. You cannot invoke a class, you cannot invoke a method, you cannot invoke anything except call its API. API can be RESTful JSON, XML, whatever you like it to be, but it's API exclusively. And finally, how many of you are familiar using design-driven development? No. There's one. Anyway, it's the important thing, and then the part that I think that most fail is not understanding what is the scope of a service. Now, we won't have a time to go through that today, but it's important to understand that it's not a technical division in any formal way. It's a business division about context that should be developed as a service, and that has nothing to do with our technical assumptions like, oh, I'm going to develop a service that communicates with a database. That's not a microservice. If you're going to develop a full functionality like registration service, users management service, that's a real division. So they're completely independent. At least here you can see the only way you can access them is through proxy, which we're going to speak about very soon. I'm going to skip this one. I like using this quote when speaking about services because this quote has absolutely nothing to do with microservices. However, it describes microservices better than object that we are using today, because what I'm really trying to say is that microservices are probably the best implementation of object-oriented design, because we truly have objects. We have well-defined interfaces that you can communicate with those objects. It's just that now they're called services. And another one also speaking about, but by Uncle Bob. Just as an example of microservices and how old they really are, you can take a look at the architecture of Unix or Linux, right? The whole operating system is a set of microservices, which is quite different than Windows, for example. But not every, but almost every single program in Linux is a tiny program, very specific, does a very small number of things, or maybe only one, and has a clearly defined input and clearly defined output. That's how the whole operating system works. Most of the programs in Linux are extremely small. They are a few kilobytes, right? And this is an example of microservices in Linux, right? We have one command that does something, produces output, we pass it to a second program, we pass it to the third program, we pass it to the fourth program, and by combining those very simple and small services, in this case programs, together, we accomplish the necessary complexity. So actually, the complexity is accomplished or solved through the combination of very simple programs or very simple services. So, Microservices do one thing and only one thing, whatever that one thing is. And the cool thing about microservices is that finally you can, how to put it, you can innovate, right? What happened, at least to me before, is that I work on application X, right? And that application is developed in, let's say, Java, right? I cannot try Go language, at least not at work. I can do it for my hobby, but I cannot try something new because I'm stuck with what I have. If I'm very unlucky, I might even have to deal with COBOL application, right? Simply, you cannot change things easily. And without being able to change things, you cannot innovate, you cannot improve. It's impossible to change, but it's very hard. Whatever is your layer for communication with a database, let's say it's a Hibernate, you cannot just switch it to something else to try it out. And if it doesn't work, who cares, the system is down, right? We already spoke, it's truly loosely coupled. There is no really coupling outside of API. And another thing that I really like is that without breaking a monolithic applications, I'm talking all the time about big system. When I say a monolithic application, I mean huge application, right? You cannot really go agile. You cannot have small teams. Because how can you have a small team if the application is too big? And if the application requires 50 people to maintain it, you cannot have a small team. You can have 10 teams of 5 people that are gonna be in conflict with each other all the time, simply because the responsibilities are mingled between you. And that's one of the best rules about the teams. And they heavily use microservices is in Amazon. Kind of the maximum size of the team is 2 pizzas. That's how, if they can be fed by 2 pizzas, that's the size of our team. But you cannot truly accomplish that unless actually what you're doing is equally small. If what you do is big, you need a big team. If what you're doing is small, you can get away with a small team. And finally, testing. And how can you effectively test something that is huge? I'm not saying that you cannot test it. You can test it, of course, but due to all that coupling, due to the size, what you're testing, even if it's fully 100% automated, might take an hour, might take a day. Now you might say, hour is not much. It is. It is when actually you can accomplish the same with only a few minutes. The same is valid if you're going towards continuous delivery or continuous deployment. Again, you cannot do it effectively because everything is so big. So, decentralization, we're going to speak about it later. Now, there is no free lunch, right? There are problems with microservices. And I'm now coming back to my point that microservices until recently were not really a good solution because they were too expensive to maintain. Because operational complexity increases drastically, right? Before you had one application, you just put it on a server, change 5 configuration files, and you're done. Now you need to deal with 100 things. 100 things potentially requiring completely different and often conflicting dependencies. One service is using Java 5, the other one Java 8, so you need both JDKs installed. One is this dependency, the other one is that dependency, they're conflicting and all those things. So your operations are becoming very complex. Now, you need some kind of configuration management, which we're going to speak about very soon. And the reason why they're becoming so popular today, microservices, are containers. Without containers, it's too expensive. It's too expensive simply because you need to deal with so many dependencies of your host. Or you can create a virtual machine for every service, but then your resources are going to die very soon because virtual machines are very expensive. So Docker and containers are something that enable microservices. And if you look at the companies that use microservices for a long time, you will actually see that they use containers also for a long time, or at least many of them. It's just that containers are now available to us, and before they were reserved for just big guys like Google, for example. And finally, the advantages or time that you're going to save as a developer, part of that time needs to go to operations. And it cannot go to simply traditional operations because manual operations are not an option anymore. There's too many things. It needs to be some kind of DevOps. And this is not really a problem, so I'm going to skip it. Advantages. We can scale microservices in a way that was impossible before. We can scale them in seconds. And we can scale them without actually occupying too many resources. It's going to be much faster and much cheaper, as you will see. Then resilience and fault isolation, right? If a microservice, assuming that you did it right? If a microservice dies, until you bring it up again, what happened? Only a tiny part of your system is down, assuming that you developed it right. So you have isolation of your failures. If your huge application dies, let's say that you did not cluster it, it dies, what happens? There is nothing, simply, it's dead. Innovation, we spoke about it, size, decoupling, repetition. And this is one of the features of microservices I really like a bit more than others because there is no long-term commitment, right? If you worked on big applications, you probably notice that kind of, if the application was designed in 2000, you're probably playing with technologies from 2000 or something like that because it's not easy to change. But with microservices, it is. You just, you want to try something new, throw the service to the trash, create a new one. It's easy because we are talking about a couple of hundreds of lines of code. If you're wrong, just get it back out of trash and plug it in again. If you make a mistake, you're going to make a mistake worth, let's say, a week of effort. But you're not going to put back the whole year effort at danger, right? So containers. You cannot do microservices without containers effectively. And you can do it. It's going to be very expensive. Any of you using containers, Docker? Okay, less than I thought. All the rest, you should. That's the message. Do it. And if you're Windows users, then don't do it. Wait for a few more months until new Windows server is released because it will have containers as well. And that's kind of, for Windows users, the proof that something is really, really good is when Microsoft finally decides to jump in. You need a proxy because the worst mistake I made with microservices is to make a call from one service to another. That breaks easily because as soon as you move somewhere, your whole system dies. So you need to have a proxy. And I guess that most of you use the proxy one way or another, no? Nginx proxy, HA proxy, and stuff like that. Okay. Minimalist approach. If you're, for example, Java and you use WebLogic or JBoss or something like that, those huge application servers, don't even try to continue using them with microservices, simply because if you're going to have 100 of something instead of one of something, 100 times huge servers is a killer. It would never work. So go for a minimalistic approach and never, ever, ever try to implement, develop, use, whatever you do. Don't try to do something because you might need it one day. And that's the problem with big things. And when I say I don't like monolithic applications, not only those that I develop, I don't even like monolithic tools to use because the point is pick a tool or develop only parts that you're gonna really need today. And since it's so easy to change, when you need something else in the future, you're gonna add it. Don't try to stuff things inside just for the sake of who knows, we might need it. Configuration management, we need it. Cross-functional teams, since everything is smaller, you can finally do it and you should do it. Have a small team, 5, 6, 7 people, and make sure that that team can do everything from DevOps to development, testing, however is your division, but make it in one go. So that you have a team that is capable of, from requirements all the way to production. Everything. And I assume this is not really related with microservices, but in general, you need to version your APIs because if you don't, things are going to break very soon with any change. So I'm going to speak about, depending on how much time I have, I'm going to speak about some of the things that are really required for services. I'm not going to speak how to develop them because you all know how to develop stuff. I assume that you all know. As long as you don't go crazy and develop more than you should, you'll be fine microservices. And as long as you learn how to actually split them and what should be one service, which also is not that hard, you'll be fine. But you will definitely need, because one of the points of microservices is that we want to be very fast, right? We can develop every hour. Deploy every hour. We can deploy maybe every day if we want to and when we want to. But in order to support that, you need continuous deployment. I'm going to skip continuous integration because continuous integration is just an excuse for people to do nothing. Kind of put Jenkins 1 build 3 tests and you have continuous integration. We're all happy, right? It has no real goal, what's trying to accomplish. Continuous delivery, on the other hand, is a real deal because it has clearly specified goal. And goal is everything is automatic after the commit and it can go to production if I want to. That's a really clear and specific goal, and you know what you need to really do. And what you need to do is to have everything automated except the coding itself. And same thing for deployment, just the difference that every commit goes to production. But once you reach one of those 2 points, really there is no... The difference in speed with which you're going to go is just amazing. And the money that you're going to earn to your business is even more amazing because they will be getting features much faster than before, right? So Docker, for those of you who don't use Docker, Docker is like, you all use virtual machines one way or another, right? Okay. It's like using a virtual machine without the overhead that virtual machine has, because what each virtual machine has is duplicated operating system. So if you have 100 virtual machines on a real server, you have 101 operating system when I count hypervisor. That just kills your resources. With containers, no. Simply because they don't duplicate operating system, they live on top of the kernel or Windows when it's released. So they are isolated processes, meaning that no process in a container will be in conflict with any other process, just like virtual machines. So it means that truly you don't need to worry when you deploy a container whether it will affect something else on your system. You can deploying containers like crazy, and you know that there will be no conflicts between processes or dependencies or anything, simply because everything is isolated and container contains everything. Meaning, if you need an application server, it's inside of container. If you need JDK or whatever you're using, Python interpreter, it's inside of container. Your files and everything is inside. It's like it's kind of like creating virtual machines just well. It's immutable. The beautiful thing about immutable, any of you using immutable deployments? No. Oh. Beautiful thing about immutable deployments is that you know what you're going to deploy, right? When you deploy in a traditional way, immutable way, you deploy something to testing environment, you test it, then you deploy that to production environment and it fails. Why it failed? Why didn't you test it? Simply because servers are never the same. There are always differences in some packages installed or some configuration files in something that will potentially make your application fail for not being tested in exactly the same conditions. With containers, you have completely immutable deployments, meaning that I can put it on my laptop, I can put it on a staging server, I can put it in production, and it will be exactly the same. They're reliable, trust me, they're self-sufficient, meaning that there is nothing that a container needs that is outside of itself, meaning absolutely everything is packed inside. It's pretty much like containers for shipping. We don't know what's inside. We just know that we need to put it somewhere, and that's about it. With the difference that it has API. Scalable. Since they're immutable, since you can put them in literally, it would take you a millisecond to make a container up and running, if done right. You can scale it easily. If, for example, your traffic increases, you can have easily a script that just multiplies that container on a separate server. You know that it will work exactly the same. It will happen in a matter of milliseconds, maybe seconds, and you're good to go. And you don't need to think about much, except proxying maybe. Okay, we'll skip this difference between virtual machines and containers. And it's just one example of a container, but simply everything is there. Runtime is there, application server is there, even database can be inside or not, depends really on a case, and your whole application, your artifacts, whatever they are. So if you want to go microservices, really don't bother without containers, because all this complexity is gonna kill you without it. Or if you absolutely want to not go without with containers, use virtual machines for each service. Now another advantage is deployment. It's simply physics tells us it's easier to move something that is smaller than something that is bigger, and that applies to microservices versus containers, or sorry, monolithic applications. We're a bit running out of time, so I'm going to skip to the more interesting things. You will need, one way or another, some configuration manager. Any Puppet or Chef users? Yes. Okay, please stop using it, move to Ansible. It's so much better. No. Huh? That's good. No, because the rules of the game change, and that's why Puppet and Chef are kind of lagging behind, because what you need to do with the configuration management with containers is quite different than without containers, simply because with containers you don't worry much about configuration, you don't worry much about dependencies of your application, you just worry that your system is nicely updated, has firewall and God knows few of those things, few users that you need, and that's it. So you don't need monster applications like Puppet and Chef to do that with all their clients, architecture, and things like that. Ansible is so much easier. Next thing, you really need service discovery, right? If you have 1,000 microservices, that means that 1,000 different or more configurations are required that are extremely hard to manage. Where is the database? We don't know, we need to go to some properties file and configure it. Where is this service? We don't know, we need to configure it, right? Now, configuring so many things is extremely complicated. Even with Chef and Puppet, if it's a big system, it becomes really hell on earth. Service discovery is very simple. And there are tools, I can show you later. You bring up the service announces itself, says, oh, I'm running on this server, on this port, and stores the data in some registry, right? And then somebody else, whomever needs those data, asks from registry. So it's kind of, we're going towards zero configuration files logic. No configuration. Ask your registry what you need, and it will give it to you. Okay. So tools, just quickly. If you don't use service registry, service discovery, try one of those 3 combinations. Actually, don't try Zookeeper. It's becoming awful, but etcd, confd, or console template. Small tools, and it's example of another usage of microservices. Not only that we develop microservices, but we are choosing small tools that do very specific stuff, microservices in a way, instead of big do-it-all tools that just kick us later on. Proxy. You need a proxy. You cannot make this service speak with this service because you don't know where this service is, right? So everything needs to go to some proxy like HA proxy or Nginx. At least that's my recommendation. Never ever Apache. It's too slow. Another thing is that what we really want to do with microservices, among other things, is zero downtime, right? If you have huge applications, what you're doing probably is that you have a night shift, you come to the office the night of the deployment, you turn down the application, do your magic, whatever, and then bring it back on, right? There is a second, a minute, hour, night, some period of time that your application is down. Now, people have been doing blue-green deployment for a long time with big applications, and the idea behind it is that you have always 2 versions running, right? You don't bring down your server, you bring a new release up, then change the proxy to go to the new release, and then put it down. No, so there is no downtime. But with huge applications, let's say that your application is so huge that it occupies 5 servers. That means that you need 10 servers in order to run things in parallel. On the other hand, with something small, it's so much easier because you can run them on the same server. Okay, later on you can see slides, they're online, if you need more details about how something as how they should be implemented. Okay, finally, not finally, but another important thing, if you want to scale things, and we already established that scaling is one of the most important aspects of any business, and that includes ours, you need to stop treating your servers as entities, right? The same way as you probably have a server called, I don't know, Garfield, that you know that it hosts application A, and then you have another server that you know that it hosts application B, and it's extremely expensive way to do stuff because you don't use your resources efficiently. Because that first server has maybe 100% of CPU utilization, but has 50% of memory utilization, so you have 50% wasted, and things like that, right? And you cannot move things around easily if servers are dedicated to something. Same thing like when you have application that needs 4 processors, that's good. That's what you think is the limit. But you don't you don't code use processor 5 because you don't care about it. Now, where we are shifting right now, and you'll see actually presentation of Kubernetes later on, that with more details, is that we treat all the servers as one big entity and just deploy wherever it makes more sense, right? So you have microservices, and you don't say deploy to the server number 5. You just say, okay, deploy it wherever there is most memory available, or most CPU available, or whatever your criteria is. So, and we can do that. Again, we couldn't do that until recently because it was reserved for big guys, Google-like, but now we can because there are tools. There are tools that appeared only recently, and for containers I wouldn't use Mesos, but Kubernetes and Swarm are another example of very small tools, very specific, they do specific things, and in this case, the specific thing that they're doing is that they make sure that your services are going to the right destination. You don't specify where something should be deployed. They think about those things. And the good thing is that if a server is down, what happens? Nothing special, because those tools will just move your services to another healthy server. And finally, when your big application goes down, you know about it. You know about it simply because it's down, which is awful, but at least you know about it easily. When you have a huge number of services, that becomes also a bit more complex because you have 1,000 services. Which one is down? We don't know. We know only when they use reports. That's not a good way to do it. So there are different ways to provide SEP healing, but the gist is always based on actually depends on the level. I'm going to speak about system level healing. So the point is that you need to have a system that will ping your services every 10 seconds or something like that, and if it doesn't respond, redeploy, right? Again, if everything is automated, if you use something like Swarm or Kubernetes, that's easy, right? Just ping it every 5 seconds. You can even write scripts by yourselves that ping, because how hard it is to ping something, and make sure that they're redeployed when they fail. Again, you cannot do that if you treat your servers, if you decide in advance where something goes, because if you decide that it goes to server 5, maybe server 5 is down, and that's why actually it doesn't work. So for a long time, we've been very reactive, meaning that we wait until something fails in order to recuperate from a failure. But the point that we're trying to accomplish here, especially with microservices, that we are trying to prevent things from happening, meaning that monitor your memory. If it reaches 80%, scale up. Monitor your CPU. If it reaches some percentage, scale up. Monitor your hard disk, and a bunch of stuff like that. So try to be preventive. To finish, because I'm running out of time, immutable over mutable deployments, that's the way to go because that's much more reliable. Use containers if you can for that thing. Use small things, small tools, and develop small applications instead of big ones, because your life will be much less miserable. Except maybe operations, they're going to go insane, but that's a separate topic. Everything automated always, no manual procedures. Use service discovery. Don't try to predefine any value, because that's hard to manage and very dangerous. Everything should be dynamic. There is no concept of something being static anymore. You don't know where you're going to deploy. You're going to deploy wherever it makes more sense. And use small tools. It's easy. We all have Google. You need a certain job to be done. Find a tool for that. Don't find a tool that does more than what you need. And apply the same logic when you develop your applications. Develop what you need, not what you think you might need one day. And yeah, it's not that things on the right don't matter, they do matter, but really I would suggest that you go with things on the left. Questions? None? Please. Yes. But what is the challenge in that? Okay. For the same thing? Okay.
Java, and that works for .NET and so on.
Yeah. First of all, you should rely on automation. If you're not, somebody designs that script that does something, whether it's Ant or Maven behind it, nobody really.
Well, they are automated. The problem is that the cost of support of the farm of those tools is creeping all the time.
Now, assuming that you don't go crazy with tools, but use tools that really matter, I'm not. At least my experience is not that it's more expensive. I had much more trouble with the expenses of big stuff like Oracle ESB, right? I mean, that's expense, first in money, but second in learning it. At least in my case, my experience is that it's easier to learn 5 small things than one big. But again, that's me. Maybe it does not apply to everybody. And the more important thing is that if you decide, okay, we're going to have this tool, we're going to use it, only this tool. Most likely you're going to get stuck with that tool forever and ever, and you will not find out that there might be better ways, right? So experimenting and using things, I think it's very important part of what we do, because if we don't, then we don't advance, and then we get stuck with Java 5. Another question? Yes, please.
With Docker, so the question, how do you think, what type of services or what kind of logic, it does not make much sense to run under Docker, to make it deployable with Docker?
I would say the big things don't make sense. Let's say that if you have an application that occupies the whole server, right? You probably wouldn't, huh? It depends on the type of the database. But let's say if it would be Oracle, I wouldn't put Oracle in a container because most likely Oracle should run on its own server and you wouldn't have anything over there, right? So big stuff, I think don't benefit with containers. Smaller stuff benefit because you can combine them on the same server without fear of what will happen when we do that, right? And especially things that don't change over time. Kind of, when you deploy Oracle, you're probably not going to change it for 5 years. You might update every 2 years a version and then change the configuration file every once in a while, but that's about it. Now, if you can choose, I recommend actually that you don't use those because ideally each service should be ideally self-sufficient, meaning that if service needs a database, it has its own database. I really dislike the shared databases because shared databases again increase coupling, right? We don't know who's using this table. So we cannot change this table because nobody knows who's using it, right? If you separate databases, each service with its own, then you can actually do many nice things that you couldn't do before. You can make a choice. Oh, this service would be better off with no SQL. Oh, okay. We put Mongo. This service would be better off with relational database. We can by splitting things, we can choose the right tool for the job, right? And but to go back to your question, something is big, don't use container because you have no real benefit. And that's why microservices containers very well together. Yes, please.
Yeah, I have a question about monitoring of services, and actually, do you use some tests that are more advanced than ping, like tests that will check some logic or configuration of the service? Because ping says just only that host is response, but no idea about logic and environment inside of it.
Yeah, pings. With pings, I never test whether functionally it works. I just make a ping on some API, some request that I know, for example, that will go to the database but fail if the database. But apart from that, nothing truly prevents me from pinging both the service and the database separately as well. However, in a process of deployment, continuous delivery or continuous deployment, you already tested everything. You know that everything works functionally. You just need to make sure that things continue being alive, that nothing failed, if that makes sense. Does that answer your question?
Yeah, so you test the whole system while deployment phase, and don't check if configuration is still the same as it was after deployment.
Yeah, but no. Actually, in my case, I know that configuration is not the same after deployment, because if I deploy it with Swarm, release 1 is here, release 2 will be somewhere there, so configuration will change. But configuration, I tend to have very dynamic configuration. My configuration is basically a database. I store everything in a Zookeeper or etcd, that very, very small database, but configurations are always dynamic. And everything normally goes to proxy, and proxy is very dynamic with those configurations as well. But zero configuration is at least my goal.
Okay, thank you.
Hello, I like examples because with examples you can very clear understand things, and I will tell you how I understand your concept of the microservices, and you correct me, is it right or is it not right?
Go ahead.
For example, I have a website and I have a comment section which is standalone microservices, which has own web server, which has its own database. And for example, I have to deliver another services which will be sent email for the commentators. So it's completely two different standalone application which had own databases and only communication through the API.
Yes, without now entering into discussion whether that's a good division, because it really depends from case to case. But yes, those would be two services. One is comments, the other one is email, and then if calling comments need to send email as well, it would go to the service for sending email to.
And the bad approach when I put database outside of the microservices and put it somewhere on the standalone server, and both of the microservices will be depend on this database. That's bad approach, yep?
Yeah, I put databases outside of service for simple reason, for scaling. If I would never ever scale, and I have those cases, then I put database inside of container, so it's all packed together with the database. However, if I need to scale, and especially if I have a system that will recuperate for failures, I want database to be separate so that I can do things like kind of, maybe I want to replicate database, but I don't need to scale the service itself. Or maybe I need to scale the service, but don't need to scale the database. Just because it allows me more flexibility in deployment and scaling and recuperation. But when it's very simple scenarios, I tend to put database inside of container together with a service.
Okay, thank you.
I have a question that actually relates to your last answer.
Okay.
When you are putting database that will be used by many services, for example, for scaling, is it a good practice to wrap up this database as a service by itself, and other services will actually discover database like any other service?
No, if I can help it, I don't have a database used by many services. If I can make that decision. So there is
Yes,
one
but
database.
you said that you are doing this when you want to scale, and then
Yeah.
many services will use the same database.
I expressed myself wrongly, my mistake. What I want to say is that one service, one database when possible. It's just that I don't package them together in the same container. So they're separate entities, but it's still one service, one database. I can deploy them separately, but nobody speaks with this database but this service. If somebody wants this database, it should go through the service itself, because service knows what to do with data. I think it's very dangerous, even without microservices and containers, to have multiple entities working on the same set of tables, because then you have too much coupling. So I expressed myself wrongly. I wanted to say one database per service, but separated separately deployed.
Yes, but what if all those services need to use the same data? They need to share data.
Yeah, they should all call the service dedicated to that database. So if you have 5 services that need data from database X, then you would call the service X to request the data, to put the data, to delete the data. So everything goes. Imagine that service is a front of the database. It's a database client that you use instead of going directly there. And assuming that it's divided, there is no service dedicated to operations with a database. There is a service with certain functionality and that has a database related to that functionality.
And the last question, you recommended, one of the recommendations is Consul, the
Yes.
service discovery and configuration. This service, we are considering it right now, but it's like in 0.5 version. And if your service discovery doesn't work, it's kind of problematic to rely on it. Do you have examples of using this service in production?
Yes, I used it in production and haven't had any problems. Now, if you want to go with something that is proven throughout years to work, go with Zookeeper. Zookeeper is kind of exists for a couple of years, and we know that it works.
But you just mentioned not to use it.
No. I said if you insist on something that is proven throughout the years to work, then it's Zookeeper. I think that Zookeeper, first problems with Zookeeper is that it's very big. It occupies too many resources. It's hard to handle, and its API is a bit horrible when compared to etcd and Consul. But on the other hand, with etcd and Consul, you're going with something that is not proven to work, apart from trusting me.
Thank you.
I think that I need to leave. Yes, your question. Yeah, I was about to say, I mentioned Kubernetes, and there's the guy. I don't know, when do you have your session? 3:30. 3:30. Yeah, the other 3:30, we continue the same subject, but hands-on this time, right? Or something like that. Okay, more than mine. Thank you, everybody.